Bismillahirrahmanirrahim. Assalamu alaikum. My name is Jamshaid, and so today we are going to discuss the design of a calculator by using microcontroller 8 mega 2560. So first of all, we have to construct a block diagram, and then its flow chart, how is it work, and then we have to write a assembly code which we will run through the atmel or through other softwares to generate its hex file, which will we import to simulations, and then we check our simulation working. And then after all of it, we have to implement it on the hardware as well in our labs or in our practical life. So first of all, we are going to discuss about its block diagram. So we have to construct, here you can see, we have to construct a calculator performing two operations, addition and subtraction. So first of all, we have to declare the registers, input output registers, and then we have to give the input to the registers, and then with the help of these two operations, addition and subtraction, we will perform these operations on our Proteus or our atmel as well. And these operation results will stored in last register, which will get us on the output which we take, such as port C, port B and port A, whatever we want. So first of all, we have to look towards the block diagram. Here you can see, first of all, we have to load direct all the registers values, and then we have to apply two conditions, addition and subtraction. So if our conditions, such as if our port consists of 0x08 0x0c, it means if it is 0x08, after comparing, then addition operation will perform, and if it compares to 0x0c, then subtraction condition will perform. After all of it, the load direct to store to our register, and it will give us the final output on port D. So now we are going to move towards our flow chart. So now you can see, first of all, we have to load R16 register and then R17, and then we have to declare all the input and output ports, and after it we have to apply the conditions, such as if port C is equal to 0x08 after comparing, and if it is condition is true, then it will add the port B and port C inputs, and if it is not, then it will move towards the next condition, which is 0x0c. It means if it is 0x0c after comparing, then it will perform subtraction operation, and after it, after first operation or after second operation, whatever the operation is true, it will move towards the port D, which is known as output, and at last we can get output through our segment or LEDs, etc., and at last our code will end. So now we are going to move towards our final code. So as you can see here, first of all, I declared and start our program after originating with the help of .org command 0x0000. So after it, as we can discuss earlier, we have to load direct R16 values, which is 0, and after it we have to declare R17 register value 0xFF 8-bit values, which continues to 255, means start from 0 and end at 255. So after these two direct, load direct, intermediate, after it we have to set directions of R16 as well as R17 as output, and it will write the program. After it, we have to declare all the inputs, such as register 18 pin B input and register 19 pin B input. It will take a second input from keyboard and store it in 19. So such as I am giving R18 input and R19 input, it will conduct R18 input and then move towards the next output. So now we are going to apply these conditions. So first of all, it will the program will run, and then when this condition approach, then it will see if R20 cross 0x08 compared 0x08, and if this condition is true, so our branch equal to condition runs, and then our code will move towards the addition module, which is this, and then these are 18 and R19 inputs add, and it will goes to port D. After it, our program will again run, and if this condition will true, CPI, such as if this condition is false, then it will move towards this, and after it this. So if this condition is true, then our code run to next line, which is branch equal to subtraction, then this program will move towards this subtraction module, and after it our subtraction will occur with the use of sub command, which is a command used for the subtraction operation. So after it subtraction, our output goes to our port D, and after all of it our program will again jump to with the help of rjmp command to start, and this in this procedure our program will run again and again in a loop. So now we are have a look on our Proteus simulation circuit. As now you can see here, here I use a keyboard and microcontroller. So first of all, I have to import its hex file from it here, and after it our circuit will run. So such as these are our outputs, which is connected to our port D with the help of this IO's inputs, and these IO inputs are connected to our inputs such as port P, port C, and these IO input or outputs operations are connected to our output port, which will give us output in the form of 7 segment displays and will give input in the form of keyboard. So this is our final Proteus simulation circuit. So after it we have to perform its PCB, and then we will perform it on a hardware and with the help of using microcontroller Arduino. So we will perform it on our Proteus or hardware software as well. So that's all from my side. Jazakallah.